In this series of videos, we're going to unpack the various alignment types which are offered when we run Project Assist. Now, rather than run through the entire list in one go, we're going to unpack them gradually over the course of this short series of videos. The aim of this is to develop the knowledge of the alignment usage types and at the same time see how they can be applied in context to a real design. So for each video, we're going to be adding to this particular project and exploring more of the alignment types as we go. We have created 4 alignments in this project to begin with, and these are all going to be building the framework of Islet Street. So we have the main centerline alignment, which is along the existing centerline or crown. We have a left edge of bitumen alignment, which will be where our proposed edge of bitumen will finish. We also have a proposed right edge of bitumen alignment. And lastly, we have an alignment which is representing the saw cut. And you can see both the saw cut alignment and the left edge of bitumen alignment actually stop well short of where the main road string will be finishing. We've also created a template. So this is the template which will be applied. Fairly straightforward, but the REB and LEB will be controlled using the alignments. The saw cut, as you can see, is not actually in this particular template, and the reason why is because Project Assist will actually add the saw cut in as a variation and interpolate the elevations between the centerline and the LEB. The remainder of the template will stay the same. Let's run Project Assist. So the first thing to note is that when you run Project Assist, the types that are chosen on the right hand side are based on the AI reviewing your alignment name and the position of it within the drawing. So it's determined here that Islet Street should be a road string from the list. It's then determined that the left edge of bitumen and the right edge of bitumen alignments are likely to be road edge connection or string control, which they are. They're going to be controlling the edge of our template. The saw cut, as you can see here, has been picked up a saw cut control, and we'll see the result of choosing saw cut control in a second. A word of caution though, if you decide that you do not want to use a particular alignment within the workflow, what you do not do here is pick nothing, because nothing is actually telling the AI that if it ever sees a particular alignment type listed in here, that it shouldn't ever use it or determine that it should be used later. In a second, when we're in the workflow manager, you'll see we can actually choose ignore, and that's what you should be using to not include an alignment in your particular design. An example of where you may pick nothing is for an alignment that maybe was generated by auto curve returns, an alignment that's maybe been created for plotting, or maybe an alignment that you have used for pipe design. Typically these would not be used within the workflow, and therefore you would maybe go and choose nothing. Let's click confirm. In the workflow manager, we'll always have the main road string listed at the top, and then any alignments that are also associated with that road string will be listed underneath. The first thing you should always do is go and make sure that you have your template selected for your road string. The AI will not select what it believes to be an appropriate template. This is something the user must do. Once you've selected your road string template, you can then go and choose how each of the alignments that is associated to that road string should function. So for the left edge of bitumen, we have the choice of maintaining the current row crossfall and simply positioning the code, in this case the left EB, onto that alignment. We can also have the LEB placed on top of a string, which is created by Project Assist for us in the background. Underneath that, we can then decide what happens with the saw cut. Now, because we have no saw cut on our template, the software will add one in as a design variation for us, interpolating the levels between the centerline and LEB. Lastly, we can choose what happens with the right side, and the right side in this case is simply going to be positioned onto the alignment whilst maintaining its current slope. Now at this point, all we're going to do is click on compute. Now, depending on whether or not you've checked the box on in the settings, every time I run compute on my particular workflow, I'll be prompted to name a thread which will get created in the background. So we're just simply going to call this Islet Street, and then click OK. We'll just close down the PDF for the time being. Then we're going to go and open up the vertical grading for Islet Street. So as far as the software is concerned, it's simply just created a road string for us, and it's generated vertical design that we'd normally expect to see. If we right click and open up a cross section, we can get a little bit more context as to what's going on. We're going to right click one more time and open up the section data form. So this shows us all of the different variations that have been applied to Islet Street at this particular chainage, chainage 190. So first of all, the left edge of bitumen is being controlled by a string in offset and elevation. A saw cut code has been added in for us, and you can see that there. In addition, it is interpolating the elevations between the LEB and the centerline and being positioned using an alignment. And lastly, the REB, and the REB is being positioned onto an alignment but just simply maintaining its current slope. So we're in a position now to actually start to edit this. So if there are aspects of this we do want or we don't want and we would like to change, we can actually start to go in and manage all of the content that's being created for us. Let's just very quickly look at the vertical grading of the LEB string. So there's quite a bit that's happened here. First of all, we've got an auto profile entry with reference point. If you want more detail on how this gets created, have a look at the road widening playlist that we've created. In addition, we've also got a design constraint or design constraints being applied in the background. So as far as these particular types go, you can see that the road string creates the main road. Then the road edge connection or string control is being used to manage the EB codes, and then the saw cut control is being managed to, in this particular case, add for us a saw cut into the road cross section.